Good evening from New York. The nation's biggest airplane manufacturer, Boeing, has bet its future on a revolutionary new airliner. It's become the fastest selling airplane in Boeing history. And within less than a year, passengers will be flying on what the company calls the Dreamliner. But a former Boeing engineer, as well as some senior engineers inside the company, say this plane is being rushed to market and could be unsafe to fly.
Ladies and gentlemen, your 787 Dreamliner.
In July, amidst much anticipation and fanfare, Boeing rolled out the 787 Dreamliner. The event was broadcast around the world in 9 languages. The demand is so strong that if you ordered a 787 today for no less than $146 million, you would have to wait 7 years for delivery. When you strip away the paint, the 787 looks like no other commercial airliner coming off the assembly line anywhere. Boeing has bet its future on this airplane, largely made out of high-tech reinforced plastics known as composites. A former longtime Boeing engineer is coming forward for the first time tonight because he says Boeing and federal regulators are compromising the 787's safety by rushing this new technology into the skies.
The problem is all the unknowns that are being introduced and then explained away as if there's no problem. Well, this is how you sell a used car, in my mind, is you just make everybody comfortable and say there's no problem.
Vince Weldon is a 46-year veteran of Boeing and a pioneer in aerospace design, including the use of composite structures. In his long career, Weldon played a major role in a wide range of projects, from the revolutionary wing design of the 727, which enabled it to land on short runways, to the Space Shuttle Orbiter.
Booster ignition and liftoff.
Weldon spent much of his career supervising studies for NASA and the Air Force on weapons systems. Boeing thought so highly of Weldon, they had him research how advanced composites could be used in the next version of the 787 and future commercial jets to make them lighter. Weldon says composites used on military airplanes for years have lots of advantages.
It's a lighter structure for a given weight than aluminum would be.
And therefore more fuel efficient.
Right, and then you have the advantages of less corrosion and better fatigue resistance, so you can possibly get a longer life out of the airplane.
The 787's revolutionary design is setting a new standard for passenger comfort with large windows and better lighting. Boeing says the Dreamliner will save the airlines 3 billion gallons of fuel over 20 years. This should significantly improve their bottom lines. Well, given that, one can certainly see why an aircraft manufacturer, particularly a large one such as Boeing, would be very interested.
Oh yes, and all of them are, and it has panned out quite well in past uses, such as the B-2, which is a bomber, which is virtually all composite airframe. However, it's not a commercial jetliner, and it doesn't have to face some of the negative factors that are inherent in composites.
What are the disadvantages, questions, and dangers?
The biggest problem with composites of the type that Boeing is using on the 787 is the lack of toughness. Toughness means resilience. Toughness means plastic deformation that absorbs shock if you have a negative event of a crash landing.
Weldon and other senior aerospace engineers still inside the company were so concerned they decided to break ranks in 2005 to criticize the 787 design. They feared for their jobs if they stepped forward, and so they say they needed a well-respected Boeing voice who was close to retirement.
I would say that they needed a spear point. And it had to be somebody with a record of accomplishment in developing new hardware.
So Weldon spoke to his supervisor. And what did he say?
You're dangerous and you need to find another job. And so I just said, well, that's a waste of time.
So then you take it to the ethics organization.
Yes, I did.
And you're confident at that time that it's going to work itself out?
I thought it had a good chance. They told me now, well, you're not only credible, you're super credible.
The list of issues that Weldon and others have with the 787 program is long and includes major safety problems, as this February 2006 email written by a Boeing engineer indicates. Weldon and his supporters think the 787 program will turn into a nightmare if problems are ignored, and they worry about a possible engineering disaster much like the Space Shuttle Challenger and Columbia. In this August 2005 email to a Boeing top manager in charge of ethics investigations, an engineer wrote that if we do not rectify these issues, the 787 program will be the last for the Boeing company and will irreparably damage our reputation and finances. Boeing says they reviewed the complaints but found them to not be a concern. Weldon and his colleagues say they believe Boeing never did a truly independent review and that the company simply did not want to hear bad news about the 787 program. To get a better understanding of how composites are used in commercial jets, we talked to engineer Joseph Rako of Exponent, a Northern California aerospace consulting company.
When I look at an aircraft, one that's built with composites, would this include the fuselage?
Yes, absolutely. Most of the very light jets that are coming out on the market use composites heavily for the fuselage. The 787 uses composites heavily for the fuselage. The skin of the Boeing 787 is about 100% composite structure.
And the fact that the 787 has a composite fuselage or body makes the 787 lighter than an aluminum plane.
In airliners, we're always trying to save weight to increase fuel efficiency, to increase payload, to increase the number of passengers that we can carry. Composites do not corrode in the way that aluminum does, so you can have a more humid environment in the cabin so that when you land at your destination, you aren't all dried out and dehydrated.
Last year, Rako co-wrote a paper that looked at composites in aircraft accidents.
One thing that is interesting about the difference between metals and composites is that metals are a ductile material.
What does that mean?
A ductile material is a material that deforms permanently before it breaks. So, as an example, you can look at this flat piece of aluminum. This is aircraft aluminum. And if you were to bend that piece of aluminum, it would look like this. Composites are different. They're a brittle material. A brittle material is one that does not deform permanently to any significant degree before it breaks in half. So if you look at these two pieces of composite, they were actually at one time one flat piece of composite. Mm-hmm. And what I had done was I bent it until it broke. And you can look at it now and see that there is really no obvious indication that it was bent.
For Weldon, the brittle nature of the graphite and epoxy composite used in the 787 could mean trouble if the airplane crash lands. To illustrate his concerns, Weldon has called the attention of regulators to the 2005 crash of a European-made Airbus in Toronto, Canada.
That plane came in bad weather. It hit long on the runway. It overran the runway and went into a ravine that was about 30 feet deep. Now, when that thing first impacted the ground and it crumpled the fuselage, the aluminum fuselage was bent, but it was intact.
Weldon says that gave the 309 passengers and crew enough time to escape the smoldering plane just before fire engulfed the entire fuselage.
With a composite airframe, the fuselage would not crumple, it would shatter. Okay, and then when the plane nosed over into the ravine, that shatter hole would be there for the fire that's going into the airplane. So instead of everyone getting out, a far less positive result, in fact, a tragic result, at some level would have occurred.
People say, well, you know, if you're in a plane crash, you're going to die, and when your time's up, your time's up. People believe that. It is absolutely false. People survive plane crashes all the time.
Mary Schiavo is an aviation lawyer and former Inspector General of the Department of Transportation, which oversees the Federal Aviation Administration, which is supposed to be the nation's aviation watchdog.
One of the things that you have to do now, if you're going to build a new airplane, is you have to meet certain survivability levels and impact levels.
Over the years, the FAA, NASA, and industry have studied passenger survivability based in part on drop tests like this one conducted in 2000 when the FAA dropped a 737 aluminum fuselage with dummies connected to computers. This drop test was not part of any certification process. Rather, it was a study. From these kinds of tests, the industry learned how to make aluminum airplanes more survivable or crash-worthy.
You have to be able to have a crash-worthiness standard of 30 feet per second. And the metal planes, by and large, are supposed to meet that and do meet that, and you're supposed to be able to survive that kind of a plane crash. And that's very important because people do.
But the verdict is out for some like Weldon on whether the 787 is as crash-worthy as an aluminum plane.
They're not doing anything close to the thoroughness of the drop test that they did in 2000. They're not doing that for the 787. Basically, I believe, because if you can't stand the answer, don't ask the question.
But Boeing, which declined our repeated requests for an on-camera interview, wrote us that they were asking the question by doing tests to make sure the 787 has the same or better survivability as a similarly sized aluminum airplane. They say they have conducted simulations and actual drop tests of a portion of the 787 to prove the crashworthiness of this new passenger airliner. The company would not share the details of those tests with us, saying they were proprietary. Since Weldon felt Boeing wouldn't listen, he presented his concerns to the FAA, which was already experiencing a learning curve when it came to composites.
The FAA has admitted recently, only within the last couple months, that there's a lot about composites that they don't understand. And if the FAA doesn't understand it, then neither does Boeing.
The FAA proposed new guidelines designed to ensure that the 787 is as crashworthy and fire-resistant as aluminum planes. Boeing says they will comply with the FAA's guidelines. Weldon is so worried that he wrote this letter to the FAA saying that the rules don't go far enough and that it will be very difficult for Boeing to make the 787 as crashworthy as an aluminum plane.
Let's assume that we use some special devices that Boeing has been looking at to improve the crashworthiness of the current design. And what that is to put some what we call snubbers underneath the cargo floor. Now that will provide some limited amount of improved shock absorbing capability. It's relatively unproven, but it's a Band-Aid. It's nothing close to the potential of metal frames.
Airbus, based in Europe, just announced that they will be manufacturing their answer to the Dreamliner, the Airbus A350, with a composite design for the fuselage. Airbus considered including an aluminum fuselage frame for the airplane, but not everyone was pleased with that. According to Schiavo, the airlines were not happy about the extra weight from the aluminum.
Airlines complain to Airbus that they're adding weight and they want the lighter composites because it's cheaper. So it comes down to money, and that in the airline world, that's first. That's on the list, number one.
Another cause for concern with composites, says Weldon, is fire.
Let's talk about combustibility, the fire danger.
Yeah, well, let's compare it to aluminum. Aluminum reflects heat away. Now you'll see many pictures of the aftermath of a crash with an aluminum airliner, and you'll see a lot of the hull isn't there anymore. You can see where it melted. But the people were long gone before that in general. It's going to be a much different situation with a composite airliner. If the bottom of the airplane is shattered due to the crash landing, there's an open hole for the fire to get directly into it.
The smoke from burning composites fabricated out of graphite and epoxy is so toxic that the FAA has already effectively banned it inside airplanes currently in service. Although the exterior of the 787 is made from this type of composite, in an email, Boeing says that they do not have any indications of adverse toxicity associated with the use of composites on the new 787. And then there is the issue of lightning.
Airliners are subject to lightning strike, and in fact, on average, they're hit 1 or 2 times a year. I've actually been on a severe lightning strike flight in which the passengers were screaming. And I was one of those who helped to calm them down, because I said that the airplanes are designed to disperse the electricity, and don't worry about it, we're going to be fine.
But composite materials, as engineers and aviation experts know, have a record of poor conductivity.
They're plastic, and so there is nothing to direct the lightning around the wing, which is the fuel tank, or even the center fuel tank, rather than into it. And so the issue is, well, what are you going to do to direct the lightning around it rather than into the structure where it will cause a disaster?
To deal with the lightning problem, Boeing is, among other things, embedding copper alloy mesh inside the airplane's surface to disperse lightning strikes. But copper alloy has problems of its own. Some engineers, like Weldon, are concerned that the vast temperature difference on the ground and at high altitude will cause the metal mesh to expand and contract so much that it will damage the composite structure. Even more troublesome is a lightning strike potentially damaging a metal fastener in a vulnerable place like the wing, setting the stage for the fastener to fail. Boeing says it believes special coating on the fasteners will protect the airplane in a lightning strike. The FAA says that before the 787 will fly, Boeing needs to prove that the chance of lightning sparking a fuel tank explosion in flight is less than 1 in a billion. In a statement provided by Boeing, they say that with each new generation airplane, quote, "We work diligently to ensure we create designs that enhance the safety of our products," end of quote. Composites are the future, says Rayco, and Boeing, he says, will eventually get it right, continuing, he believes, its remarkable safety record.
I'm excited to ride on the 787, and I'm excited to fly in composite aircraft.
You wouldn't have any personal concerns about walking aboard and flying transoceanic in it?
Not at all.
The first 787s are scheduled to be delivered in May 2008 to Japan's All Nippon Airways. So if there are issues with the composite design, as Weldon and others insist, it seems late for the FAA to be discovering them.
When the FAA does something like this, it's usually because somebody's complained, and it's usually to cover cover themselves. And that's not bad. If the FAA has been made aware of a situation and now they're going to step in and require something, good. They should.
But aviation expert Chiavo says the FAA doesn't often challenge the powerful aviation giant. That may be due in part to the revolving door that swings between the FAA and Boeing.
The revolving door between the FAA and Boeing is in good health. There is no permanent restriction on moving between the industry and the FAA for employment. And it is not unusual at all to see someone either take an early retirement or simply leave the FAA and go to work in the industry that they used to regulate.
In November, outgoing FAA Chief Marion Blakey will become the top lobbyist for the Aerospace Industries Association, whose biggest member is Boeing. Moreover, the 2 top FAA officials in charge of certifying the 787 have ties to Boeing. Ali Barami worked for McDonnell Douglas, an aircraft manufacturer that merged with Boeing in 1997, and John Hickey worked for Boeing before joining the FAA in 1990. The FAA declined to do an on-camera interview with us, saying that if the 787's new technology doesn't meet the safety standards already established, then the plane won't fly. As for Weldon, he says at the time of his complaints, Boeing assigned a special investigator to the case.
Do we know what it finally concluded?
Well, I was told what the findings were. They made that assumption that crashworthiness is material independent, which is patently absurd.
The ethics investigators transferred the complaint to a technical review committee, says Weldon.
I found out by late in 2005 that nothing had changed. In fact, their focus had been on changing the requirements rather than doing anything about my allegations. In other words, the design wasn't changed at all.
In 2006, Weldon was fired for allegedly making threatening and inappropriate remarks about a colleague. Weldon says he was fired because he would not stop criticizing the composite design of the 787. Even after all he says he's endured, Weldon still considers himself a Boeing man.
I love the company. They're paying for my retirement. I'm concerned about Boeing's long-term success, not for any perceived short-term stock advantages, bonuses, and things like that.
Weldon says he decided to sit down for this interview because he and others inside Boeing continue to be concerned about the safety of the 787 design.
Boeing is way down the pike, of course, now having had the rollout, and we need to deliver by May of 2008 in order to stay on schedule. And to let this thing go on for this length of time, it's just practically unbelievable to me.
As Boeing and Airbus use more composites to manufacture commercial airplanes, a debate has emerged over how the airlines can best maintain and detect damage of this reinforced plastic material. Airplane makers say visual inspections are sufficient to detect any serious damage. But many composite experts say visual inspections are inadequate, and they urge airlines to invest in high-tech tools if they want to fly a composite airplane safely.
One of the selling points of the new 787 is lower maintenance costs because the composite airframe won't corrode or rust. Boeing says the maintenance costs will be cut by 30%. They also say that detailed visual inspections on a periodic basis should be sufficient to detect serious damage to the composite material. We asked composite expert David Moss if he agreed.
No. Almost anybody I know in the composite field does not agree with that statement. It is very easy to have serious damage in a composite that is not visible. I know the reason that they made the statement, but I believe that's a false statement.
You said you think you understand the reason. What reason could there be?
During certification, they will intentionally put flaws and they will intentionally impact the composites to create internal damage that can't be seen. And then they will apply repeated loads for 2 lifetimes of service and prove that that damage will not propagate. It's a complex situation. The statement that if a composite has no visible damage, it therefore is perfectly safe to fly, is not true.
Vince Weldon, a former Boeing engineer, explained how composites were marketed to the airlines.
They've even gone around to the airlines and they give them a piece of aluminum, beat on it with this hammer. And of course it'll dent immediately. And they said, now take this piece of composite structure and beat on it with a hammer. And the hammer bounces off of it.
Pretty impressive.
No, it's not impressive at all to anyone who knows what's actually going on. But it's very deceiving because where the damage is, it's micro cracking that you can't see, and you have to use ultrasound inspection to determine it. But what it does, it builds up internal damage to the structure. Once you start getting a flaw in the composite structure that starts being able to entrain moisture like water on a humid day, and every day you fly, you're going to go from a hot, humid environment to a cold, very cold, dry environment. And every time that water freezes, it expands and it breaks a few more fibers. And what do you have after 3, 4, 5 years of that happening? See, these are elements of composite structure that aren't fully understood.
Commercial airplanes go through a lot of wear and tear, everything from baggage carts banging against them to turbulence in the skies.
Your point is, well, this can be deceiving because the damage would be in the interior.
This is also subjective. You know, this is like a convenient operation in order to keep things flying and tell everybody that everything's okay. But everything may not be okay.
Well, what I have here is a piece of composite laminate that has been impacted.
Joseph Rako, with the consulting company Exponent, showed us what damaged composites look like.
I don't see it. It all looks like just every other piece you've shown me.
Right. There is no strong indication of the impact on the surface of the composite.
But then Rako took this damaged piece of composite and put it under a special ultrasound scanner in the lab. This ultrasound machine is similar to technology used to see a baby inside a mother's womb.
As the machine scans back and forth on the composite piece, we start to see the image develop on the screen. The information that this machine provides allows us to quantify the level of damage and correlate that level of damage with any sort of potential safety hazard that it is associated with.
And as we spoke earlier, if you did a visual examination, you wouldn't have any indication of this.
If you remember when we looked at the piece, there was not this level of indication of damage on the surface. It wasn't until we put the piece into the machine that we were able to see what sort of damage lies under the surface.
At a time when manufacturers and airlines are trying to cut back on costs, this new technology is not cheap. Just one of the Sonoscan machines costs about $150,000. Moss advocates the use of inspection tools like tap tests, ultrasound, shearography, and embedded sensors to help detect damaged composites, especially when a composite part has a history of trouble.
To sort of ignore the tools that you have at your disposal because you want to save a couple of hours of inspection time is almost criminal.
Boeing and Airbus use inspection tools during manufacturing, but say they are only needed if damage is visible once a plane is in service. Fueling the debate about how to keep pace with this new material are vague federal guidelines and the history of an older Airbus airplane, where visual inspections did not catch damage. In 2001, American Airlines Flight 587 crashed after its composite tail fin broke off and landed in Jamaica Bay, New York. Federal investigators ruled that pilot error, rather than composite failure, was the cause of that accident. But some people were skeptical.
In 60 years of commercial aviation flying large jet aircraft, no pilot has ever manipulated the rudders to cause the tail of his airplane to fall off. It's always easier to blame a deceased pilot who can't defend himself.
Todd Wissing is a pilot who flew the Airbus A300, the same model that crashed in New York. He says there will always be controversy over the cause of that crash. What is clear, says Wissing, is this technology needs a more thorough inspection regime.
After 587, we started paying attention to the way that the inspections were occurring on these composite materials. What struck us was that these were 21st century materials. We think that you should use sophisticated 21st century methods to inspect them that can find the damage.
Sometimes pilots and mechanics can see problems with the composite tail section on the Airbus in question, says Wissing, specifically with the rudders and elevators when they soak up water and other fluid.
Sometimes on the walk around you could look up on the underside of the tail and see a bubble, and you would have to check to see whether that was a repair or whether that was a new problem, because if water got underneath the skin of the tail, it would look pretty much the same as the repair. So you'd have to check with maintenance to see if it had been repaired.
But damage is not always visible, says Moss, who told us about an incident on March 6, 2005, in which problems were not caught in time.
This was a Canadian aircraft, Air Transat, that was actually taking off from Cuba, and all of a sudden the composite rudder, which is the control surface on the fin, simply departed the airplane.
Which is to say it broke off.
It just broke off almost completely.
That Air Transit plane was an Airbus A310, and it landed safely. Today, foreign air carriers, American Airlines, and FedEx fly some of the Airbus planes in question. After the rudder incident, the FAA issued a mandatory one-time inspection of certain Airbus airplanes.
They said, not only look at this rudder visually of the remaining ones in the fleet, this time use a tap test.
No problems were found. But 8 months later, FedEx did find something.
During routine maintenance on a FedEx airplane, they found a massive area that had debonded from the inside of an A300 rudder.
It was about 3 square feet of previously undetected damage, according to this March 2006 National Transportation Safety Board report. In addition, hydraulic fluid had leaked into the composite material, which could cause further damage. Canada's Transportation Safety Office is still investigating the air transit case. In light of the FedEx incident, the NTSB urged more thorough inspections of certain Airbus rudders. The NTSB also wrote that there may have been dangerously close similarities between the air transit incident and the American Airlines crash in 2001.
The NTSB recently wrote the FAA saying, hey, the airworthiness directive you have issued with respect to that rudder loss, you didn't go far enough. They've specified you have to do repetitive inspection, and in fact, they're using non-destructive inspection now.
But these repetitive inspections on the troubled composite parts are outside tap tests, not more sophisticated tests like ultrasound. Wissing and others want to see more done.
Our concern is that they've tried to establish the visual and tap testing as the basic foundation for composite inspections. We're not catching the damage that's occurring. If that were good enough, we'd catch it early and consistently. We're not.
But that may be changing as airplanes are made with more composites. When Boeing delivers the first 787 Dreamliner to Japan's All Nippon Airways in May 2008, that airline will have invested heavily in ultrasonic equipment and a corps of mechanics trained by Boeing to care for the aircraft. So it seems 21st century inspection methods are on the way to some airlines. And for Wissing, who in 2002 stopped flying the troubled Airbus airplane because he felt they were not properly inspected, he may one day fly the 787 Dreamliner. That is good news.
Pilots are analytical. We put safety as our top priority. We use 21st century inspection methods with these new materials. Then we have complete confidence in the product, and we have complete confidence that we can get in the airplane with our passengers and go fly, because that's what we do.
2 weeks ago, Boeing announced they were postponing the first flight because of what they said were production delays. They acknowledged that these delays can cause significant compression of the program for testing and safety certification. But Boeing still plans to deliver the first 787 on time 8 months from now.